Okay, class. So let's continue our discussion on the application of first order ODE, no? So, manaman ta sa exponential growth and decay of Newton's law of cooling at tatakaron sa mixing. Okay, so mixing is another application, naputay application sa first ODE, no, with regards to our mixing problem. So, mixing occurs frequently in chemical industry. So, in these problems, we will start with a substance that is dissolved in a liquid. So, nga ni usually ang problem. Okay? So, na a certain substance nga dissolved in a liquid and then a certain liquid pod will be entering and leaving a holding tank. And then the liquid entering the tank may or may not contain more of the substance dissolving. Usually, atong problem ani kay kanon na ay salt. Okay? So, liquid leaving the tank will of course contain the substance dissolved in it. So, kaninga concept, it's very important para makabalot unsa na to pag-solve. Okay? So, ang atong assumption here, class, is that the concentration of the substance in the liquid is uniform throughout the tank. Pero the more ta mag-solve ani nga, kuan, dili na kay ta mag-think ani, no? Pero it's a very important concept because if the concentration of the substance in the liquid is not uniform throughout the tank, we cannot use this formula. Okay? And another assumption nga ako din emphasize po is we will be encountering problems where the liquid entering the tank or sorry, the rate ga-enter siya is the same as the rate nga ga-exit siya because to eliminate the kanang problem nga more variables ang ga-change because in this certain problem ang ga-change na we want to know no ga-change ang di ba mo man na ang idea sa differential equation there's a certain variable that is changing, okay, the rate of change of a certain variable in this case katong substance ga-change ang iyahang amount kibali, okay, because there's a certain concentration po ba that is entering the tank with that substance or without that substance. And either way, katong nga substance um will change ang amount niya will be changing over time. Okay, so para mas ma-visualize na to, let's have this example. Ah, dili sa diya. Let's have this formula or differential equation nga ma-create na to from our mixing problem. So let's have Q of T now. May nag-regret kung anong mao ni ang atong gisunod nga kuan no variable kay sa Q of T man god we already use this variable when we're talking about linear and Bernoulli pero ayaw lang mo ka confuse class Q lang yapat na gamiton or you can use any variable that you want. Pero in this case, sige, Q na lang siya. So, Q of T is the amount of substance dissolved in the liquid in the tank at any time T. So, let Q be the amount of substance. So, kung kabulutan nga amount na siya, in this problem, particularly, we should be mindful of the units. Kay, usahay, kung masayo, kung di man guta kabalo mo analyze, sa unsay unit day sa imuhang certain term ba sa imong equation, dili pud na to ma-consistent and marong na ta sa atong solution. So for example, when you say the amount of substance atong i-assume as Q, Q must be in for example, kilograms. Okay? Kaya mo man na ang imong amount of substance, di ba? Unit kung pila na lang siya sa imuhang tank. Okay? In kilograms or grams. Okay? So, the amount daw or the rate of change of the amount of this substance over time, okay, is equal daw to the rate of entrance minus the rate of exit. Ana lang. Okay? So, it's very straightforward. No? So, tanaw lang na to, class. When you have dq, this is the change of amount of substance. No? So, for example, in kilograms or grams. Ni. So, this will be mass. Okay? And ang among denominator will be change of time. So this must be in seconds, minutes, hours. So this is time. Okay, this is time. Okay. So this term must be okay, ato man ang gi-minus di apod aning rate of exit. This term must also have a unit that is mass over time. Okay? mass over time gihapon eh. And this is very important kay usually itong mga problem is tricky. Unya basin ma-input na ninyo diretso ang number without considering the units, marong na gid mo ana. Okay? So, mura ra gud nagkuan class. For example, nalimot ka sa unsa di ang acceleration. Kung nalimot ka ba in terms of differential. So, acceleration is dv over dt, di ba? Pero kung nalimot ka, tanaw lang nimo ang yang unit. The unit of acceleration is meter over second square. Okay? And then the unit of your velocity is meter per second. And this is in second. So if you divide that, you can get times 1 over s. That is meter per second squared. And that's how you check, okay, tama day ako ang unit. dv over dt day siya. Okay? So, yun, nabot ko, ana. I'm just emphasizing kung kabalo mo tanaw sa unit ba sa inyong equation. Okay? So, again, ako lang sa nairisan, gubot na kayo. So, this is mass over time. Okay, so that must be the unit aning imong entrance and exit. Pero dili ra mo siya na naka-straightforward. Imong rate of entrance dili siya diretso ihatag sa imuha. Okay? Ang ihatag sa imo is ang flow rate of the liquid entering and the concentration of substance in the liquid entering. Okay? So kaning flow rate, ato na lang ning i-name as rate man ni siya no. So ato na lang butang R sub 1 niya S sub 1. Okay? Sa exit put flow rate ra gyapon class minus the times the concentration. So R1 times S1. So kini R1 nya R2 mo man itong rate no. So this is ang unit ani class is kung rate siya, di ba kung rate siya, ang over niya is time. So the rate will be volume per time. Mao na ang imuhang unit sa imuhang R1 of R2. S1 and S2, we're talking about concentration man. So when we're talking about concentration, it must be the amount divided by its volume per volume niya. Okay, that's the concentration. So if we multiply R1 and S1, we can get dayon volume per time. Okay, tawag ko Sir Bert. Times mass per volume. Okay? So, kung makancel ang volume ni mo dira, you will get mass per time. And that is consistent sa atong unit sa dq over dt. Correct? Okay? So, kanalin yung tanawang class. Kung malibog mo, tanawa lang, it should be flow rate volume per time multiplied by mass per volume. Mauna na imuhang rate of entrance or exit. So, depende na dayon sa given sa mo sa problem. Okay? So, again, when in doubt, check the units if they are consistent with each other, kada term. Okay, para mas ma-embed sa inyong malas, an example. Sige. Suppose we have this problem. The tank contains 1,000 gallons of water. Okay? Note lang na natin, 1,000 gallon daw siya. In which initially, 100 pounds of salt is dissolved. Okay? So, i-visualize ninyo, class. Naka 1,000 gallons of water. Nanay ka 100 pounds of salt. Nga gi-dissolve nimo dito sa 100 gallon of water. Okay? So, brine, ang brine daw nato. And, pero naman na ninyo ma-encounter kung nakay mixing na. Brine is a mixture of water and salt. So, muna mo salt water. No? Ang brine daw, imong sulod nimo dito sa tank. And it runs in at a rate of 10 gallons per minute. Okay? And each gallon nga ni sulod glass contains 5 pounds of dissolved salt. Okay? Naakay rate, then naaday kay concentration. Okay? Later, ato nang i-identify tanan. So, the mixture in the tank is kept uniform by steering. And this statement here, dili ka siya gamit sa to ang analysis. Kay, at gibutang na niya class to emphasize nga we can analyze our problem based sa ato ang first order. Ang ma-create man gud nimo is ang first order ODE because of this assumption, okay? But mao lagi establish na ni siya nga fact, no? Next, runs out at 10 gallons per minute. So ninyo siya brine runs out. It's because kung nagsulod ka de brine class niya, initially pag yun imong salt kina dissolve nimo sa water. Of course, what will come out is brine also. di man imposible man nga nag-mix kag water ug salt tas ang mogawas kay pure water. Okay? So, of course, ang mogawas there is also brine. And it runs out at 10 gallons per minute gihapon. Mo na akong giingon. Actually, formality ra ni siya, no? Pero, ang imong rate class of in or entering and your rate of exiting is the same. It's because we want to ensure that there's a constant volume of water. See, later, ato na makita. Kung dili day constant ang volume, complicated atong solution. Okay? So the question now is, what is the amount of salt in the tank at any time t? So ang pasabot lang ani is getting the general solution or sorry, particular solution. Okay? Katong ano na lang nimo is time. Kanang input na lang jud ko sa t and sa q or either sa ila. Okay? So let's now identify the given. Una ginating identify class para madali atong solution is of course ang R1 S1 kay mao na gamit R2 ug S2 karon dili gyud siya pareha sa tong Newton's law of cooling nga diretso bitaw siya nga dili na ta moagi kung na natay differential equation ang ato ang solution is always gonna be the same pero lahi lang siyang values mo C1 ug K. Pero here mga class we have to solve from the differential equation gyud because you will have different values of R1 S1 R2 S2 for different problems. Okay, sige. So let's solve. So let's identify unsa man ang karon ang flow rate. So ang R na to, R1, R2, S. Sige ni. R1 will be um the flow rate that is volume per time. S will be mass per volume. So kana lang tan-aw lang din nimo ang trick ana is tan-aw nimo unsa nga mga given diri ang volume per time ang unit o unsa ang mga given ang mass per volume. And then we just identify, ga-enter ba ni siya or ga-exit? Okay. Tingnan siya dire. Um, una sa tani class. Mention mo siya dire, runs in at a rate of 10 gallons per minute. So, unsa man ni? Gallon is volume, minutes is time. Okay? So, makabalota nga, this must be R1 because it runs in, it is entering. Okay, di ba nga tong formula is entering minus exiting? So, this must be your R1, the 10 gallons per minute. Okay? And then, next, each gallon contains 5 pounds of dissolved salt. Makain kala 5 pounds, di ba gusto tag mass per volume, mass raman ni siya. Pero kini ang imong clue, each gallon contains 5 pounds of dissolved salt. Meaning, ang concentration dahil nga ni-enter is 5 pounds per gallon. Di ba? Tungod ani nga statement. Dili siya necessary nga gibutang niya ang per volume ni mo dira. Sabton gid mo siya sa sentence. Okay, again, each gallon contains 5 pounds of dissolved salt. Meaning mo niya itong ni-enter na concentration. Ang 5 pounds per gallon. Okay? Next, okay, manatag R1 ug S1. Ato na po ta sa R2. Unsa man ang ni-exit karon nga rate. Ningon siya diri, naraw. 10 gallons per minute gyapon. So, butang gyapon nato 10 gallons per minute. Okay, ang S2. Okay. Diri medyo kuan. Diri ang complicated. Diri ang unknown value na to class. Nga naman, ang S2 nga concentration, ini-exit nga concentration kay bali is wala ta kabalo sa amount of salt. Correct? Kay nag-change man gud imong amount of salt that is in your tank. It's because of the additional salt nga ni-enter. And it's because of the mixing actually. No? Naap kay ni-enter nga um ni-enter nga brine. So the amount of salt changes sa sulod sa tank. So of course, the amount of salt that is exiting wala ta kabalo. So that will be Q. Mao man na atong gustong hibaw-an actually. The amount of salt that would be Q pounds. Okay, ato lang consistent sa atong unit. Q pounds per, now mo na siya. Ang S2 nimo, since it's a concentration, dili ka pwede magbutang og Q lang, Q pounds. It should be divided by volume. So, what is now the concentration nga nag-exit? The concentration that is exiting is actually the amount of salt at any time divided by the volume. Now, the volume is constant. Mo na yung giingon. If dili constant ang volume, you will have a variable here sa ubos. Pero since it's a constant in og out nga rate, wala na change ang volume. So, unsa man ang volume? Gitagaan na tani diri sa first. So, the volume is 100 1,000 gallons. So, it should be that exiting, ang concentration nga ga-exit is the amount of salt at that certain point in time over volume of 1,000 gallons. Alright? Dili man gud pwede nga value sa ni class because unsa naman day ang atong variable, unsa man day ang ga-change atong amount. It must be nga naa kay um variable diha within your equation. Okay? So, muna niya ato ang R1, S1, R2, S2. So, I hope it's understandable. So, unsa man atong dq over dt? Entrance minus exit, that would be R1, S1 minus R2, S2. Okay? So, ato na yung input na ng class. R1 is 10 gallons per minute nga. Consistent naman ang atong mga unit direct class. So, di na ako i-rewrite ang unit na that would be 10 times 5 minus R2 nga 10 times Q over 1,000. Okay. So dq over dt is 50 minus 10 over 1,000, that is 0.01 Q. Pwede ra na pwede ra sa may fraction. Bahala na. Okay, so there are different ways, actually two ways na makasolve ta ni class. More ways pa gani. Pero ang pinaka-obvious is we can separate this variable separable. Kaya mo 50 is just a constant manggot, so we can factor out negative 0.01, and then that leaves us with Q minus 5,000, no? I hope na gets ninyo. Kay para, atong bottom ko natin, variable separable. Pero there's also another option which is to rewrite this in linear form. And naan na siya sa atong next nga topic which is ang falling objects o ang RL circuit. Pero karon, pakita lang tamo nga naka-variable separable siya, and then on the next topic, ato siyang i-linear. Para lang, for the sake lang ba makasolve ta og linear ODE. Okay? So, after this, we can now separate the variables, that is dq over q minus 5,000 equals negative 0.01 dt na. And then we can anti-differentiate. We'll have ln of q minus 5,000 equals negative 0.01 t plus c. Alright? So, we can have q minus 5,000 nya erase aning everything sa right. Negative 0.01 t plus c. Same lagi pa itong button class. Kabalo naman tayo na shortcut na ako, that is C1 e to the negative 0.01 t. And natay 5,000 dira, so Q is equal to 5,000 plus C1 e raised to negative 0.01 t. Okay, this is our general solution. Pero dili pa ni final. Ay, sorry. Ay, magkabala ka. Sakto, ay tarong akong PDF version na ni. So, this is our general solution. Okay, karon napatanong man because we want to solve C1 pa so that we can have particular solution. Okay, gani class, again, ang gipangayon ni is ang particular solution. Wala na tayo arbitrary constant dira. Okay, so let's have another page ng empty. Okay, so karon, how are we going to solve the C1? Di ba usually we can solve C1 if we have initial condition or boundary condition. In this case, sa may hatag sa to, ang wapa na ito nagamit diri class is kani nga value. Ano man mo siya initially, nado siya 100 pounds of salt nga dissolve. So meaning at time zero, meaning wala pa ka nag-add og brine dira, no? So we have at time zero, our Q must be 100 pounds. Ang amount sa atong salt is 100 pounds. So atong Q kanina is atong general solution is 5,000 plus C1 e to the negative 0.01 t, no? So, Q is 100 equals 5,000 plus C1 e to the negative 0.01. Nya kanay, mahimo raman ni siya 1. So, C1 must be 5,000. Hala, say po class. It must be negative. Oh, it should be negative. Paki-correct na ako sa PDF. I think ang PDF kay naka-positive siya. Karon pa nako nakaan. It should be 100 minus 5,000. Okay, C1 is negative 4,900. Again, paki-correct yun ko sa PDF class. Okay. Upload naman guro na ako. Good. Okay, Q here is 5,000 minus 4,900. Matong C1 e to the negative 0.01 t. And this is our particular solution. And this is the amount of salt in the tank at any time t. Okay? So, kung pangutan mo na pila siya after 5 minutes, after 10 minutes. So, input lang naman dali ang time. Okay, let's have another example. Kana mag-solve na kita og certain value na gid. Okay, a tank contains 1,000 liter of brine. Okay, kabalo na taan nila. Brine. Basta ang brine with salt na siya. Salt water. Okay. 1,000 liters. This is a volume. Okay. With 15 kilograms of dissolved salt. Okay. Pure water enters the tank at a rate of 10 liters per minute. And then the solution is kept thoroughly mixed and drains from the tank at the same rate. So how much salt is in the tank after 1 hour? Same lang yapang class. Let's identify the rate and the concentration nga ga-in o ga-out. Okay, ang gain nimo nga flow rate is, tingnan siya dere, enters the tank at 10 liters per minute. So, 10 liters per minute, volume per time. Okay? S1. S1 is the concentration. Karon tan-awon mo sa problem. Unsa kay concentration nga ni-enter? Ganina is brine nga ga-contain siya og 5 pounds per gallon. But in this case, wala siya gihatag nga value. Actually, it's very medyo tricky pero easy ra siya to spot. Nga naman, ningon siya pure water. You say pure water, unsa karon ang concentration sa kana nga substance. Ang substance man atong gikuan diri specifically is salt. So meaning ang ni-enter di ay is pila niyang concentration sa salt? Zero. Because it is pure water. So 0 kilogram per liter. Ato lang consistent ang ato ang unit. Kilogram siya. Kilogram lang yapon nato. Okay? So again, ang concentration nga ni-enter is zero. Kay wala kay salt ka enter kay pure water. Okay, R2. R2 is, ningon siya dire, same rate. Same rate ang iyahang pag-drain or pag-out. So, 10 liters per minute yapon. And again, it should be same rate para constant na tong volume. Okay, ang atong S2, of course, same ra gyapon sa tong first problem. We are unknown gyapon ang imong amount of salt, which is katong Q, muna itong salt, divided by the volume. Yeah, the volume ang gihatag sa to is 1,000 liters. Okay, mao na yung ga-out. Okay, so, how do you solve this? dq over dt is R1S1 minus R2S2. R1 is 10 times S1 0. Okay. Minus 10 times Q over 1,000. Sa'yo na ni class, ma-zero mo na siya. So, kung ma-zero na, natay negative 0.01 Q na lang. Okay? So, it's very easy. We can separate the variables. Pwede Q na lang ni dire, para dire na lang ang negative 0.01 dt. And then we anti-differentiate. We have L and Q equals negative 0.01 t plus c. Okay, so itong Q class will be e raised to negative 0.01 t plus c. And balik-balik na siya. We'll have C1 e to the negative 0.01 t. Okay, so this is now our general solution. Pero, need taog particular. So, how can we get C1? Initial condition. Ang initial condition yata sa ito is kining, 15 kilogram. Kaya initially man, at time zero, wala pa ka butang og pure water, no? At time zero, ang atong Q, meaning amount of salt nga present is 15 kilograms. Okay? So, substituting that, we have 15 is equal to C1E negative raised to negative 0.01 times 0. Okay, 1 naman na siya. So, C1 natin is 15. So, our particular solution is Q is equal to 15 e to the negative 0.01 t. Particular solution. Next question. How much salt is in the tank after 1 hour? Okay. Tanawa lang. Consistent yapon ta. After 1 hour. Basin 1 rin yung butang dira. Take note that the time here, ang unit sa time ito is in minutes. So you must be consistent. This 1 hour, then that is naka 60 minutes. Maura ba na usually ang masaypan sa student? Okay. At t is equal to 60 minutes. Pila daw karon ang Q nga nabilin. Alright? So, makita ninyo class, syempre if you think about the problem, 15 kilograms of salt, pero ang ni-enter sa pure water, wala siya salt nga additional. Your instinct will tell you, or common sense will tell you nga, the amount of salt must be decreasing. Okay, wala naman kay additional na salt niya, exit naman siya nasagulan siya pure water. Until such time, there will come a time class nga ma-zero na gid imong salt ani. Okay, mas maabot naman ang time nga less na ang concentration niya, sige ra kag enter og pure water. Okay? So, again, common sense will tell you, I must get a value of Q that is less than 15 kilograms. Okay? So, let's substitute there ang T. So, Q is equal to 15 e to the negative 0.01 times 60. Okay, so our Q class will be 8.23 kilograms. And this answer makes a lot of sense. Okay, kapan ako sa class. Sige, so that's for the mixing. Let's go to falling object. Isa na ka-example class, no? Falling object and duha na di ay. And then one example for RL circuit. Sige, let's discuss the falling object. So another application of first order ODE is kaning Newton's second law of motion, kaning ga-fall nga object. Okay? So, mo na itong second law of motion, no? Force is equal to mass times acceleration. Okay? So, if you remember class sa mga physics problem na to, di ba usually if there's a certain body or object that is falling, ang force na nag-aakse is the acceleration or the gravitational acceleration. Pero, pirmi na to ibutang, di ba, sa problem nga air resistance is negligible. Okay? But in reality, there's always air resistance. So if you consider air resistance, unsa naman karon ang atong formula? Unsa naman atong equation? Dili na siya as straightforward as F is equal to ma. Pero gigan gyapon na nga problem, okay? So again, ang atuang equation, it will be different. Sige, unsa na to pagkuhaan ni? Ato na lang i-imagine class. For example, lang tayo ball. Okay? It's falling, no? Okay? So, kani nga force, balikan ni man kod glass. This is the net force. Okay, if you remember, this is the net force acting. And then your acceleration is if you remember, it is the change of velocity over time. Correct? Okay, so if you have a ball here, padulong sa ubos, fall gani, di ba? Padulong siya sa ubos. So, ang force nga ga-aksaya is, iyang weight, no, which is equal to its mass times your gravitational acceleration. Okay? Pero, naapoday kay air resistance. Air resistance, of course, your resistance man siya, you will have an opposite direction to that. Okay? And that is given by kV. Okay, kV ang ihang, velocity. Velocity times your, ang imuhang constant class. And this is negative. Actually, butang na to kV na, no? Pero ang atong notation na is, usually sa physics, di ba kung asa ang direction sa object, mo na tong i-assume nga positive. So, positive ni, negative na. Okay? So, if you now add all the forces together that is acting upon this object class, remember that will be your weight. Okay? Positive man ang weight, no? Yeah. I-plus na to, aning kV, this is another one. Force acting on the object, the air resistance. So, that would be negative kV. Okay? Opposite mo sila direction. And morning mong F actually, morning mong net force. Okay? Which is equal to your MA. M times dV over dt. Alright? Now, your weight is your mass, which is the same aning ang mass, times your gravitational acceleration, which is a constant value. Okay, 9.81 meters per second squared. Minus, ang K ni mo direct class is also a constant value. And your V is velocity. Velocity gyapon. Okay? With respect gyapon na sa imong object, pero ang imong K mo na imuhang bali imong air resistance, no? Okay, wala ko na emphasize. Proportional to your velocity mo nang imong K multiplied by your velocity. That is the constant of proportion, kibale. Okay, equals M times dV over dt. So we have variable nga V dependent, nya T as independent. Kay kining M, this is constant. G is constant, K is constant, M is constant. Okay, so wala tayo problema. So if you rewrite this class into something like a linear equation, a differential equation, so that would be dV over dt. Divide na to M, both sides, para mawala ng M dire. And then we transfer KV sa Pikas. So you'll have K over M, V, is equal to G. Again, we divide 1 over M. No? Divide by M, tanan. Okay. So this is now linear in V. And pura na po ni siya mixing class nga. Tungod magud imong V sa constant, pwede ra ka mag-variable si parable ana. Pero atong i-try karon nga mag-linear ta. Okay, that's why we have this equation na dayon. Okay, pwede na din ka mag-input sa whatever value yung gihatag sa problem class. Okay, so K over M will be our P of T and G will be our Q of T. So what is now our solution? That is V, linear in V man. So V e to the um integral of P of T dt equals integral of Q of T e raised to integral of P of T dt nya dt. Okay, sige, let's have an example. Okay, suppose we have a steel ball weighing 1 pound. Yan na siya F dili. Ato lang lang kung anong siya pasabutan na. Is dropped from 2,500 feet with no velocity. Okay? So, okay na ni. No velocity, di na maka-affect sa to. As it fall, air resistance is equal to V over 8 in pounds, where V is the velocity of the ball in feet per second. So, tanaw mo ang unit class, English, dili metric. So, dapat tanan consistent ka naka-English tanan. So, find the velocity of the body at any time t. Pangitaon na tong particular solution lang, no? Pero first, i-review sa na to class. Gamay ang metric ug ang English nga naman. Kay, um, di ba usually, when we're talking about weight, kay, mamistaken na to siya as, kaning pounds ba? Di ba sometimes it's used as mass, it's used as weight. Okay? Pero, to specify nga weight siya, meaning force. Okay? Force siya, nasa ibot ang F dira. Okay? So, one must be force, dili siya mass. And then, pounds gihapon ang imuhang okay. Ato na lang i-review ha. Unsa equivalent sa metric of English. So, this is your metric and this is your English nga equivalent. Ba't na kayo agi? Yes na lang. Okay. So, this is length, mass, o weight. Ay, sige na yung mass. Length, mass, o weight, or force. Force man yun. Okay. So, sa metric, that would be in meters. English will be in feet. Okay. Iba sinay meters gihatag ba niya, mas daghag gihatag nga English, then isa na lang imong i-convert to English. Mass is naka-kilogram. In English class, unsa man na siya? Actually, in English, it could be slug or pound o nya na siya M diya. To emphasize that that is mass, kana nga pound is not a force. That is a mass. And then weight, Newton, di ba, kung metric. And then kung English, it is pounds. Usually, magud kaning pounds nga wala siya subscript. It refers to your weight or to a force. Pero para ma-emphasize pa gyud further, na siya subscript nga F. Okay? So that means, kung ako i-rewrite diri ang dV over dt plus K over mv is equal to G, all values here must be in English because naka-feet, naka-pounds, and sa pa na dira. Tanan. So that means atong G class will be dili na 9.81. If you remember, in English, that is 32.2 or pwede ra 32 feet per second square. Mga tong G. Okay, kay kung 9.81 yung mabot ang marong na dun man. Okay. Ang K na to, this is our K, kaning V over 8 diri class. Muna tong KV. Okay, muna siya tong KV. Sige, we'll have K nga 1 over 8. Okay, from our KV nga V over 8. And then, we'll have our weight nga 1 pound force. Nya that is equivalent to mg. Walang tigitay gihatag nga mass. Pero ma-extract na nato from the weight. Diba? Because gravitational acceleration is 32. Nya natin weight nga 1. So we can have m that is equal to 1 over 32. Alright? So now, we can substitute the values here na dayon. So we have dv over dt plus k na to nga 1/8. Okay, 1/8. Niya, we have m na to nga 1 over 32. V is equal to 32. So, masimplify mo na to class dv over dt. will happen to this, it will become 32 divided by 8. That is 4v is equal to 32. Pwede na siya ma-variable separable, pero try na to linear class, no? Where our P of t is 4 and our Q of t is 32. Alright, so that would be v e raised to the integral of 4 dt. Diretso na lang ko ha. Ito na i-write dire. Para na mo guide. Pero kabalo naman mo ni class. dt. Okay. So, nata integral of qt na to, 32 e to the 4 dt niya dt. So, we can have v times e raised to 40 na dayon is equal to 32. Dapat na natin na-integrate. E to the 40 dt. Alright. And then, pwede na to i-write dira. We have VE to the 40 equals, what will happen? Copy 32e to the 40 niya divided by katong coefficients imong 40, no? So that is 4 plus C. Okay, we have VE to the 40 equals 8. 8e to the 40 plus C. Right, divide both sides by e to the 40 para V na lang mabilin. So V is equal to 8 plus C over e to the 40. Nya, pwede sa nimo i-negative. 8 plus C e to the negative 40. Alright. So, di wala pa tayo particular because we need to find the value of our constant. So, unsa may giingon niya dire? Initially, there's no velocity. Okay? So, meaning, at t is equal to 0, initial time, v is 0 pod. Okay? So that means 0 is equal to 8 plus c e to the negative 4 times 0. 1 naman na siya. C now is equivalent to negative 8. So our particular solution will be v is equal to 8 minus 8 e to the negative 4t. Okay. So muna niya to ang particular solution. Okay, let's go to our next problem. Okay, another problem. A body of mass, 4 kilogram, falls at rest. Okay, nasa siya at rest rin. From a medium whose resisting force is numerically equal to 0.003 V, where V is the velocity in meters per second. What is the velocity after 5 seconds? So, dali lang kayo ni class, kaya naka-metric ta. So, hindi kayo sa mata metric ba? Sige, let's identify the given. Mass is 4 kilograms. Okay. K na to is from here, KV, that's just 0.003. And then gravitational acceleration, of course, metric mata 9.81 or kung gusto mong 10, bahala na mo. Meter per second squared. Okay, so our dV over dt differential equation plus kmv is equal to g. So dV over dt plus k nga 0.003 over m for v is equal to 9.81. Kinina na to ang p of t and this is our q of t. Pwede ra gid ni siya variable separable class. So, you can try it there sa inyong paper and then i-compare kung pareha ba tagma answer. Okay? Kung di mo ganahan magsigig integrate pa. So, integral of p of t, diretso na lang ha, that is equal to, kung ako nang i-decimal ta na class, 0.00075 dt equals integral of 9.81 e to the integral of 0.00075 dt niya dt. Okay. V e to the 0.00075 t niya 9.81. Dito na lang class e to the 0.00075 t divided by coefficient 0.00075 plus c na dayan. Alright? So that is, simplify lang natin ng 9.81 divided by 0.00075. That is 13,008. 13,080. E to the 0.00075 T plus C. Okay, so divide po na to both sides by E, kanitanan, kay para V na lang mabilin. So V will be 13,080 plus C, niya inegate na to E to the negative 0.00075 T. Okay, we already have the general solution. How can we get C? Of course, kanya to initial. At rest man daw. Pasabot sa at rest is V is equal to 0 at time is equal to 0. Okay, so same na gyapon class, we can get C is equal to, kung ato nang i-substitute dira, kompleto akong PDF ani class, pero diretso na ako karon. That is negative 13,080. So we can have a particular solution that is V is equal to 13,080 niya minus 13,080 e to the negative 0.00075 t. So pangutana is, what is the velocity after 5 seconds? So naka-seconds man ita na, no? So okay lang nga 5 diretso ang imong i-substitute. So V is equal to 13,080 minus 13,080 e to the negative 0.00075 times 5, and we can get a velocity of 48.96 meter per second. Of course, dili kalimtan ang unit. Okay, that's for falling object. Now, let's go to the last one na lang din salamat. And then I can give you now the take-home quiz, which will be submitted next week sa atong next nga face-to-face. Okay, let's have the RL circuit. Isa lang sa siguro class, yung murag exhausting na kayo. Okay, let's have the series RL circuit. No? So, RL resistor and inductor. Nga circuit niya. Giseries na siya tanan. So, what will be our equation for this now? So, if you can remember your electrical circuit, then, di ba, ang characteristics sa L and your inductor and your capacitor, they store energy. Okay? So, you will have a changing or a varying current there, okay, with respect to your time. So, at time zero, I mean, nakay gitawag nga equation for your transient time, no? And then it will arrive at a constant value din sa imong current as time goes by, no? Pero there's a certain window sa imong time nga ga-change imong current. So, muna ato ang point of interest, okay? So, at that certain time class nga gastor pa siya, the voltage across your inductor will be L, inductance niya, multiplied by di over dt. No? The change of your current with respect to time. Okay? So, therefore, if you use KVL there, di ba? We will get negative V, okay? Negative V plus VR niya, that is just R times I. Okay, ato namang na I naman na nga to ang gamiton ani para consistent. Small letter I. And then plus VL. VL is L di over dt. Okay, equals to 0. So, kung mo transpose drang V, this will be the equation. So, kung nakita ninyo class, we can recreate this, or we can transform this into a linear gyapon. O, pwede rin gyapon variable separable, especially that your V here will be a constant number. So, pwede rin gyapon. But, para maanad tag linear, try yung linear class. Okay? Tira kayo. Suppose we have this problem. We have an RL circuit that has an EMF of 5 volts, a power supply to 5 volts, a resistance of 50 ohms, and an inductance of 1 Henry. And no initial current. Okay? So, kailan na no initial current? That will be our initial condition. So, find the current in the circuit after 30 milliseconds. So, naka-seconds ito ng class. Assumption na to, ani nga, pag-solve, ani nga, problem is naka-seconds. Ang base mag 30 ang imong input, masayop ka. Alright, so if you can recall, previous slide nato is Ri, or your voltage sa imong across your resistor, times voltage sa imong inductor is equal to V. Okay? So, atong R is 50 ohms. Input again natin class I plus inductance is 1 Henry. So, pwede ra ka mag 1. Okay? Di per dt is equal to V nga 5 volts. So, if we rearrange this, para mas makita nato, we can have a linear ODE, no? Linear in V. Okay, class? Linear in, sorry, linear in V, linear in I. Linear in I. Okay, so that means our P of t is 50, and then our Q of t is 5. Okay, so masolve na to na class. I, karon consistent gyapon ta sa ato ang variable. So I times e raised to P of t dt is equal to Q of t e raised to integral of P of t dt niya dt. Right, so we have I there, e raised to integral of 50 dt is equal to um 5 e to the integral of 50 dt. Okay, and then motor pool, basin mo na is. So, that would be I e to the 50 t is equal to
Yes, sir.
5. Diretso na ako, class. Na lang. 5 e to the 50 t dt. Right? This will be copy and then divided by coefficient of 50t plus c. All right. So, let's simplify that. That would be I e raised to 50t is equal to
Oh.
50 e to the 50t divided by 10. Okay? Reduce na to ang 5 over 50 plus c. Right? And then divide both sides by e to the 50t. So we'll get I is equal to 1 over 10 plus c. Pwede na po e to the negative 50t. Okay? So sa akong PDF class, wala na akong gisakang e to the 50t. Okay lang na siya, no? Rera man na siya. So, how do you get the value of c? Atong initial condition. Okay? At t is equal to 0, I is equal to 0. Okay, ningon mo siya diri. No initial current. Okay, so we'll get a value of C class nga negative 1 over 10. Alright, so our I will be I will be with 1 over 10 minus 1 over 10. Okay. E to the negative 50t. Alright. The question is find the current in the circuit after 30 milliseconds. So at t is equal to 30 milliseconds, what will be your current? Alright? So that would be, substitute lang yung t dira class, that would be I is equal to 1 over 10 minus 1 over 10 e to the negative 50 times 0.03. Okay? So I class will be 0.078 or pwede sa nimo milliamperes which is 78 milliamperes. So that's the value of the current after 30 milliseconds. Okay? Okay, so I think that's the only example that I have for RL circuit class. And then you will have a take-home quiz, 5 item nga take-home quiz. I think each application gahatag ko diri isa ka problem para ma-practice mo. Okay, so you will need to submit this during our face-to-face meeting next week. And hopefully within this week or sa itong next face-to-face, makahatag na ko sa inyo instructions sa PIT. Okay, so that would be all and thank you so much for listening. I also upload the PDF for the ending.